This week we're going to look at linear inequalities in two variables. So these will look just like, y equals mx plus b form for the most part, except for the sign between them. So we have an inequality sign. Okay, so let's just go ahead and start this. I'm going to actually start by graphing this line. So here's the other part I have to actually highlight. So if you have the symbol greater than or less than, then this is going to be a dashed line. And this means that the line itself is not included. If you have greater than or less than or equal to, then this is a solid line. And this is, I'm talking about when you graph your actual line, you're either going to have a dashed line or a solid line. And it's based on those signs. So if you have the symbol, actually we'll talk about that in a second. So I'm going to go ahead and graph y is greater than x minus 1. So we have a function with a slope of 1, so it's 1 over 1, and we have an intercept of negative 1. So I'm going to go down and put the intercept at negative 1, and then I will graph something with a slope of 1. So that's just up 1 over 1, and I'm going to actually put a lot of dots on this one. All right, so I draw the line, position that line. Okay, and I know I said this is dashed, right? So we have a greater than, it's not a greater than or equal, so it's dashed. So I'll go ahead and, I'll just delete little parts of it. Okay, so now I have a dashed line, y is greater than x minus 1. The part that is new with this is that there's going to be some shading. So what this means is that it's going to be a range of values that is the solution rather than a particular value. So if you have the sign where this is greater than, so we have a y is greater than, this is telling us to shade above. So if you have y is greater than, this means, and you have some kind of equation here, this tells you to shade above. If you have y is less than, an equation, then you shade below. So these are things I would keep handy if you're working through the homework, because it's really this simple. If you have a greater than or equal sign, it's a dashed line. If it's a greater than or equals or a less than or equals, it's a solid line. If you have y is greater, you shade above. If it's y is less than, you shade below. So that's really all of the new parts here. And so by shading, this is what I mean. I mean all of this above this line, since it's a greater than line, that represents the entire solution set. So we could choose any point in this shaded blue area and plug it into our inequality, and it would keep the inequality true. So if I plug in, for instance, I'll choose a point, it doesn't really matter at all which one it is. That's the point negative 5, positive 3. So if I plug in a negative 5 and a positive 3 into my function, so here's my function or expression, y is greater than x minus 1. And if I replace y with a 3 and replace x with a negative 5, then I get the inequality 3 is greater than negative 6, which is true. So if I choose a line outside of the shaded area, or a point outside of the shaded area, it will not keep this true. So what we're doing is shading regions of solutions rather than finding particular solutions. Okay, so the next example here. Y is less than or equal to 3x minus 6. And what I'd like to do is first look at this sign. so it's less than or equal. So that tells me two things. This is a solid line, and I shade below. So I like to write that out immediately so that the rest of it is just graphing a line. So 3x minus 6, we go down to negative 6. We have a slope of positive 3 over 1. So from this intercept, I go up 3 over 1, up 3 over 1, and so on. Draw our line. So this one is a solid line, so I'm going to keep it as it is. And sometimes with the lines, when they look like this is more vertical, it's more steep, you're going to shade above or below it. We're going to shade below it, and sometimes it's hard. It looks more like you're shading to the right or left if the line's really vertical, if that makes sense. So you're always shading. If it says below, treat it as though it's a mountain you are coloring in below. So that would be the solution graphically to this inequality. So the solution is the graph. Okay, sometimes just like in when you're just graphing lines, the expression is not in the form that you need. So this one is, it's not y is greater than or equal to, so I'm going to solve it for that first. So the first thing I'll do is subtract x. So I'd have negative 2y is greater than negative 4 minus x. And then what I'll do is divide by, switch colors, negative 2. Divide everything by negative 2, and I would get y. And since I divided by a negative number, I flip the sign to less than, and then I get 2 plus x over 2. So I'm going to write that as x over 2 plus 2. So I'm just switching the order of those. Now, so the slope here is 1 over 2 with an intercept of 2. And I did not do it this time. So my sign here tells me, well, let's look at actually the sign right here. This says to shade below, and it's a dashed line. So I'm going to take red, and I'll color in, the intercept is 2, has a slope of 1 over 2, so I go up 1 over 2 and complete that pattern. Draw a line. Okay, and go ahead. This is a dashed line, so I'm going to delete some of these. Okay, and now I shade below. So I take a color, and I just shade the region below it. So this problem is just an example of something where you would have to solve for y first, and then graph it. And that represents my solution. Okay, so this one, these are always weird. X is greater than 5. So if you see no y's in that expression, then you're not going to have anything cross the y-axis. That's just something you should know. So I'm going to say, well, let's just graph the line first. So if you have something like x equals 5, x equals 3, this is a vertical line. And this is a dashed line based on the sign. So all I do is go to the value 5 on the graph, so which is right here, like that. It's a vertical line I'm graphing. And this doesn't have an above or below, so it's going to be shaded left or right. So which side has values greater than 5? Well, that's on the right. So I'm going to shade on the right of this. So I'm shading this region. I crossed the line, didn't mean to do that. So that is a vertical line. And this is, again, this is shaded Okay, so let's do an example of the other type of question like that. Y is less than 3. So this has no x component, so this does not go through the x-axis. It's only going to go through the value. Check one thing on that one, yeah. So this is only going to go through the value 3, and it's going to be a dashed line. This is a horizontal line. And this is shaded, it says less than, so we shade below. So this would be the line y equals 3. It's less than 3, and it's a dashed line. And it's less than 3, so then I'm going to shade below. So that would represent the solutions for that inequality. Okay, so this is the one application problem that I found from your textbook. And we'll go ahead and do this as an inequality. So it says the science club sells t-shirts and keychains to raise money. How many t-shirts and keychains could they sell to meet or exceed their goal? And the number values are given in this little graphic here. So they have a $500 goal. T-shirts are $10 each. Keychains are $2 each. Now it doesn't matter which variable you assign to each thing. So you would have two variables. So I'll do that first. I'm going to define these. So the t-shirts I'll use with X, and the keychains will be Y, and we have a $500 goal. So we actually have to create the equation here. Now, t-shirts are $10, so we need to set up some kind of inequality. So we'll have 10x, and we're going to sell keychains for $2, so that's 2y. And we have to work with this $500. So anytime you see something that says, how many could they sell to meet or exceed? So it's not saying to equal 500. So this one's giving you, you can either get 500 or more. So what we want to do, we want whatever 10x plus 2y is to be greater than or equal to 500. So greater than or equal is like saying at least. So we're saying we need at least 500. And that's our inequality. We're going to rearrange this one. So we subtract 10x. We're solving for y first so we can graph it easily. So 2y is greater than or equal to negative 10x plus 500. And then we divide everything by 2. So we get y is greater than or equal to negative 5x plus 250. Okay, and we have to do the rest of the work with this. The inequality sign says to shade above, and it's a solid line. And that's based on that greater than or equal to. So this one, it's 250. So we're going to, let's see how I want to do this. Let's have each of these count for 20, and this will be like an estimated graph, but that's all right too. So I'll have each square be 20. Sometimes you have to do this, and sometimes it doesn't work out. Oh, I can't go by 20s. See, that doesn't work out. I don't have enough values. So let's go by, let's just go by 50. And sometimes you have to change the scale just because we don't have a graph with 250 squares on it. So but let's just do that. So the intercept is actually there. It's at 250. And the slope is negative 5. Now this is going to be, well, it's actually, we can do that still. Let's change the scale on these. Let's go by 50 as well. Okay, so if we can read that, it just goes by 50. So it's just 50, 100, 150, 200, 250. And then I need to graph the slope of -5. So this part's actually kind of tricky. So let's go ahead and see if we can do it. So it's -5, so we're going to go down 5 and over 1. So if from my intercept I go down 5 and over 1, I'm actually right there, down 5 and over 1. And the question is that a slope of -5? Well, if you look at the rise over run, so I'm going to zoom in a little bit, and I told you before that if we create this little triangle, and sure, we're in a scale of 50, but we went down 5 and over 1, and so we went over 50 because one block represents 50, and we went down 250. So the slope is going to be 250 divided by 50, which is 5, and I have a negative slope on this. So what we just did is actually, switch back to that, is actually correct. And we can, as long as your scale is the same on both axes like that, then you can just treat it as though it's a regular, you can go down by 1 and over 1 and that sort of thing, just like normal. Okay, so I draw the line between these. I believe in your book it's not going to ask you to do this type of thing like scaling and everything, but it's something we do in person anyway. So this says to shade above the solid line, so I'll go ahead and do that. So the shading above is everything over here. So graphically, any value over here, any combination of x and y would satisfy this inequality.